Okay, so we're going to spend the next several sections going over biomolecules. And so, we started out, atoms, we put them together, we made compounds and molecules, and then we started talking about some larger molecules that are based on carbon, and that gave us organic molecules, or organic chemistry. And now we're going to actually scale up even bigger. So this is still going to be carbon-based, but they're going to be, this kind of scale we were working on before, we grew to that. And we're going to take another big jump here. So biomolecules are really, 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 really large. They can be hundreds of thousands, millions of atoms. Like, these can be very, very large compounds. And so, before we get into it too much, we'll do kind of a brief introduction of different types we're going to talk about, and then we're going to go into a lot more detail, one at a time. So there's 4 groups we talk about, and we're going to break them up. And in the case of amino acids, we're actually going to break that into 2 videos. It'll be one about amino acids and one about, or 2 sections I should say, one about amino acids and one about proteins. So we're going to just kind of briefly introduce them here, and then we're going to get into some kind of key fundamental chemistry stuff for how these biomolecules get put together, how they get taken apart, which are condensation reactions and hydrolysis reactions. So they're the first type of chemical reaction that we're going to talk about in this class. And so I'll make a video for each of those as well. So there'll be probably 3 in this section. And then we'll go in and section by section really dive into biomolecules. So for now, it's just a very brief introduction of what we're going to be talking about in the future. And so there's 4 categories that we're going to go through here. And the first one is nucleic acids. Okay, so this is our first type of biomolecule. And what this is genetic information. So DNA, RNA, if those sound familiar, and you know what those are for if you've taken a biology class, well, that's nucleic acids. That's what they're made of. So this is our genetic information. So this is like, the blueprint for the form that we're supposed to have. What's the difference between us and a cat? Well, we have different genetic information that patterns out to make a human and not a cat. There's probably some other key differences too, like we can be a little less destructive than cats sometimes, things like that. And then another core theme as we go through these topics is, just like we've done in the whole class overall, we've gone from small and we just get bigger and bigger. We just go from small to large, small to large. And that's what we're going to do here. These reactions that I'm going to talk about later are going to involve putting pieces together. So essentially we're dealing with larger Legos than before. So if you think about atoms as being like small Legos, well, now we're dealing with, the toddler ones. Like, they're pre-assembled, they're large, and we put those together and we make even larger structures out of these pieces. And so what it is what we call a monomer to a polymer structure. So a monomer is like a single unit. So that's like a brick. And a polymer is like when you build the wall out of bricks. There are multiple bricks in a wall. That's a polymer. So this is one, and polymer is many. And so for nucleic acids, we have the monomer of a nucleotide, which we'll talk about more later. And then that's going to polymerize. We're going to put together a lot of nucleotides. And we're going to make something like DNA or RNA. Okay? And we'll talk about the difference between these two. But what these are is genetic information. So DNA is like the master copy. RNA is like the one that you send out to the foreman building the place. If anything happens to RNA, you just whip up another copy and send it out. Not the end of the world. If something happens to DNA, if something happens to the master copy, you got problems. But we'll get into that more later. And so that's the first one we're going to talk about. And then we are going to talk about amino acids. And these are what proteins are made out of. And so these form proteins. This is probably my most favorite of the 4, by the way, the amino acids. I was really interested in proteins when I first became a chemist, and so I really enjoy talking about them. And so these proteins, this is like the machinery of the cell. That's kind of the function here. So all the stuff that has to happen in a cell is typically mediated by a protein in some way. Even stuff going in and out of the cell has to go through protein channels in the membrane. So proteins are involved in everything. How do you know how to make a protein? Well, yeah, that's what you send the copy out to do. You send somebody a copy of the blueprint, it makes proteins. You make a copy of the master, and hopefully nothing happens to that. Keep it safe, keep it in the vault, make sure nothing happens to it. That's the whole cycle here. And how do you make those copies, by the way? What's the copy machine? It's a protein. So it's this total cyclical event. And so what we have are amino acids as our monomer. And then they're going to polymerize to make a polypeptide chain. And this itself isn't a protein. We'll talk about that more when we get to it. But a polypeptide chain is just a string of amino acids that are connected together through chemical bonds. And then that can get turned into a protein, but it involves what's called protein folding. But we'll get into that later. All right, and after we talk about amino acids, we have carbohydrates. Get the carbo load for a day, or however long you want to watch the videos. Really stretch it out. And so this is like energy storage. At least for us. For plants, it's also structural. The cell wall is made out of carbohydrates. But we'll just say energy storage. And this is like your checking account. It's accessible. It's not cash money on hand. That's something else. And it's not a savings account or long-term retirement savings. That'd be lipids for that. So ATP is like the cash money. Carbohydrates, they're the checking account. Like you can spend it. Takes a little work. You got to hold up the grocery line behind you. Everybody hates you. Second you whip that checkbook out, all the carts behind you start frantically going to different checkouts because they know where this is headed. But that's what carbohydrates are. And so they polymerize our monomer, our single unit, we call a monosaccharide, or just a saccharide. It's the fancy word for a sugar. And it becomes if you got a mono, if you polymerize it, what do you get? Oh, you get a polysaccharide. And so this is like stuff like starches, any type of compound that has more than one sugar in it. So table sugar, sucrose is actually a polysaccharide. It's actually two different sugar molecules put together to make a larger sugar molecule. It's 20 times more delicious than the two by themselves. If you ever had straight up fructose or glucose, you'll know that sucrose wins the day. Alright, and then we will talk about lipids. And this is the last one, and this is, ironically, considering it's lipids, the one we go lightest on. So we're going to go lightest on lipids. So lipids are like fats, by the way. That's the joke, And this is the long-term energy storage. So I mentioned this before, but this is like your long-term retirement savings. So this is long-term energy storage. So it's very dense energy storage, but it's very slow to get at. You've got to kind of work at getting the energy out of these. So it takes a little time. You got to call up your investment broker and cash out your my retirement plan is, I think, just I got a pile of cans in the backyard, but you cash out your Roth IRA. I've heard those letters before. I think that means something. Either that or it's probably something bad in Ireland, but I think it's something we have here for money as well. But anyway, that's what your lipids are. They're your long-term energy storage. And typically our polymerization will be something like fatty acids. And these don't really polymerize so much. And we got kind of two directions we'll talk about these going. And so we can get triglycerides, which is long-term energy storage. This is what when you think of fat, you're thinking of triglycerides. So fat is energy storage in animals. And it can also make hormones, like steroidal compounds. So you can go two directions with these. So it does more than just long-term energy storage. It can do intracellular signaling. So we have our nervous system that carries information around the body. I tell my arm to move, it moves. that's a very rapid response, very fast. My eyes move when I tell them to, and they tell me what they're seeing. It all processes in the brain. But there's other signaling pathways in the body as well that don't use the nervous system, and they go through hormones. And they're a little slower, but just kind of the more regulatory stuff like make insulin or don't make insulin, or whatever it might be. Grow taller, or increase bone density, or you're pregnant. Like, all of these things are signaled with hormones. So, which come from fatty acids. So hormones are actually most often a type of lipid. And we'll talk about that. So these are our 4 categories. We're going to spend a lot of time on these. Amino acids is actually going to be broken up into 2 sections. So we'll talk about the structure of amino acids, and then we'll talk about how they polymerize and form a polypeptide chain, and then we'll have a whole section on the polypeptide chain and it becoming a protein, and the different levels of detail we talk about with proteins. But this is a nice little introduction to get us started for the next several sections, which will go a couple weeks. And you will definitely want to be familiar with the reactions we'll talk about next. I'm going to break them into 2 parts. One video for one type of reaction, another video for the other. So there'll be 3 total here. But yeah, so this is all you're expected to know for now, by the way. We're going to go into a lot more detail as we move forward, as we spend more time on this. So don't freak out. Just take them one at a time. This is just a brief overview of what they do.